Of course, we all know by now that qualitative risk analysis doesn't really work, but it has been the standard for I don't know how many decades, and until today, the majority of organizations are still practicing it because of this lack of critical thinking. And I'm pretty sure many curriculums that we're teaching the newcomers in cybersecurity are still teaching this old thinking. So the point really here is that we should encourage the new generations that are coming with, like also it was mentioned before, with technical skills and all of that. But we should teach critical thinking, reasoning, these kind of skills. I think in life or work, they are much more important than all that technical stuff. The technical stuff we can master and we can learn quickly, but not things like critical thinking. Because the generation that's coming up now cannot solve tomorrow's problems with these best or past practices that we have developed. They need to develop their own thinking. Okay, so these were the 2 points about complex adaptive systems and critical thinking. What else did we get wrong? Or some examples. Password complexity. That was in 2003, it became a NIST standard, and we have been practicing it for a very long time. We have been suffering from it. There were actually papers published, I think one was even from Microsoft, where they have shown that password complexity is not really giving us the value that we want, but it remained the standard until recently, when the person who wrote that paper said, "I'm sorry, I'll take it all back, password complexity doesn't really solve our problem." So that's just one example of what we accepted as the standard. Everyone needs to have a complex password and rotate it every month. Another example, waterfall software project management, was the result of a paper published in the 1970s. And the paper itself actually mentions that it didn't work for complex software projects, and it should only be used for the simplest software projects. Nonetheless, it became the standard until the early 2000s, where we started then thinking about agile methods. So we really have to do a lot of critical thinking in our domain space and encourage others to question us. Risk makes a difference. I try always to stick to the definition given by the FAIR Institute, and I try to avoid talking about risk when I don't really mean risk. Because when it comes up with management, as soon as you say risk, it always is being taken very negatively, no matter its severity level. So the definition of FAIR is very simple: probable frequency and probable magnitude of future loss, and I try to use this as consistent as possible. Now, of course, it's not up to me, because I have to deal with other stakeholders that come, and they have a totally different understanding of risk. So it becomes challenging. And some of these come from regulators or external auditors, so I can't really dictate to them what definition to use and change their methods. So we end up with these audit reports where everything is mentioned as a risk, and it's high, medium, or low, and I have to somehow convince them to remove the word risk or adopt our definition of risk. And usually I just ask them, okay, you say this is a risk, can you just define for me what's the loss event frequency and what is the loss impact that you have estimated or calculated? That of course makes work for them, and they don't want additional work, and most of the time we just agree, okay, let's rename it into priority. Now, once they have renamed it to priority, I can then pick it up and convert it into what I believe the risk statement should be. The same with if you have penetration testers, everything is a risk. same approach, it ends up then to be a priority. And then I can see how that feeds maybe into one of the risks I already have, or some controls that are not working, and define it then in my own way. Another issue with auditors are many of those supposed risks that they mention, they're actually control deficiencies or variances in risks. Usually they have this perception that controls are perfect, and any small deviation becomes a major risk. So for example, you have 1,000 workstations, 5 of them don't have the latest antivirus signature, they report it as a major risk. The world is going to end if we don't address this. But the challenge is that I haven't defined what threshold is acceptable. I haven't defined anywhere that says it's okay to have, 5 machines that have outdated signatures in the last 24 hours. So that was a learning, and now we define the expected thresholds or KPIs or variance and controls that are acceptable to us. Once we have it documented, they can't really mention it, unless whatever they report exceeds what we have documented as a variance level, as an acceptable variance. Many of the risks are, or supposedly risks that get reported, are exaggerated, and there I fall back on the FAIR model. I'll discuss it with the auditor, and most of the time they haven't defined a loss event, not particular scenario. So I try with them to think it through. Okay, what exactly do you think is going to happen? Let's look at it in details. How often do you think it will happen? Are we talking about a cyber criminal or a nation state? Have you considered all the controls that we have already in place? When I start breaking it up for them, they start realizing that whatever they had in mind is such a complex scenario that you can't really call it a high risk anymore. And sometimes when you don't get anywhere with them, they will fall back and say, we looked at inherent risk. And inherent risk is inherently problematic. It's this concept that you have no controls at all in your organization, and they rated you accordingly. But we know there's no organization that has no controls. You always have something. You have policies, procedures, you have culture. You can always argue that there's something guiding people or the organization to impact these loss events. And they're just, they either put a big disclaimer that they talk about inherent risk, so when I can talk to management, they don't misunderstand it, that this is our current risk issue, or sometimes they actually agree to downgrade their findings from high to medium or low or something else. And Jack wrote a nice blog post about the issues with inherent risks. Jack talked about cleaning up the risk register. That's something you can do without any risk quantification. You know the definition of risk. You know the components that it needs to have. If your risk does not have these components in them, it doesn't matter how you construct the sentence itself. It just needs to have a threat actor, an asset, an effect, and optionally also a method. If it has this, then you're really talking about the risk. And there also, when you apply this consistently, you find you can drop a lot of things from your risk register. They either get combined or dropped off or rephrased. You get a much smaller, manageable risk register, which might create another problem with some auditors. They say your risk register is so small, it needs to be bigger. But I don't know what's this magic number it has to be. That's another challenge. Maybe one more comment. When we develop these scenarios, try to define the asset as close as possible. Not all our databases are of the same value, so you shouldn't have risks here that says databases. But try to define it more closely. These are just some examples. So we're analyzing the risks associated with cyber criminals disrupting operations by encrypting and exfiltrating files via ransomware. That's something you can work with that is unique and makes sense. Or the last one, you are analyzing risks associated with disgruntled employees sharing VPN login credentials with cyber criminals, resulting in deployment of malware and disruption of operations. Frequency and probability, very simple concept. I stopped talking about probability when I talk to the business. I don't ask them what's the probability this can happen. It's much easier to use frequency. How often do you believe this will happen this year? How often do you believe this will happen in the next 10 years? Everyone has the same understanding about frequency, makes your life much, much easier. FAIR generally uses frequency only when it talks about loss events that can happen only once, like your data center burning down. Then we will talk about probabilities. And vulnerability in FAIR is defined as the probability of a threat event becoming a loss event. But I think besides that, it doesn't mention probability, and you can easily work with the definition of frequency. Making estimates and ranges. Okay, and I had hoped that some of the previous presentations actually go into more detail on how FAIR works. But yeah, many of these building blocks that we have seen, like for example frequency, how often could this happen? All of these are defined in ranges. So you define the minimum number you believe it will happen, you define the maximum number you believe it will happen, and the most likely. And then when you plug these into your computational engine, it does the calculation for you. The same principle you can use anywhere else. So when I'm asked about giving a timeline for a project, if I can get away with it, I'll try to define a range. Most of the time, I will be pushed to give a very specific date. But what happens sometimes is when you give a range, you get asked, why can't you give me a date, a specific date? Yeah. Can't give you a date because the people I have to work with, they don't report to me. I don't know what exactly their timeline is and how free they are. Sometimes management might give you the authority or might give you the data that will help you to reduce your level of uncertainty. The fair loss impact categories, we touched on them, I think, in one of the presentations. There's something also you can use, and they help you if you're working within a security department that does not realize they need to interact with the business. Mentioning these categories can help. So, because IT or security, they have this tendency to do things on their own. They don't always want to involve the business. They maybe get away with it sometimes. But if you're trying to change this mindset, if you sit in a workshop, say, okay, but what exactly is the productivity loss? Well, what exactly are we talking about? Or what fines could there be? And then they start realizing, maybe I should talk to HR. Maybe I should talk to the legal advisor. But if you leave it just at mentioning high, medium, low or something like that, anyone will make any decision and move on. But thinking, keeping the loss impact categories in mind might help you to have people change their mindset. There are a few things I learned, not directly from FAIR, but around FAIR. It's the understanding of measurement, and once you get into this FAIR community, there are two people. There's Jack, And then we have Douglas Hubbard that does a lot of work in measurement. So these two names you will always hear in the community. And Douglas Hubbard had a huge impact on how I think about measurements. What he basically says or teaches is that measurement is a quantitatively expressed reduction of uncertainty based on one or more observations. We tend to think about measurement as some precise exact number. He's arguing that's not what it is. It is a reduction in uncertainty by observing something. So what does that mean? How does that help? When you deal with consultants, they always come to you and you have a project with them, I don't know, digital transformation or something. At some point they will say, yeah, but we can't really measure the impact because it's intangible, or it's a soft measurement or something like that. And that's where then the alarm bells go off, because according to teachings of Douglas Hubbard, if something matters to you, it can be measured. It's just how you approach it. So he's basically saying, if something matters, it must have a detectable, observable impact on real life. Else, it doesn't exist. If it has no impact on our lives or organization or whatever, what do you want it for? Just don't do it. Now, if something has an impact on our organization, then we should be able to detect more of it or less of it. And if I can detect something, more of it or less of it, then I can define it in a range. And that range gives me, that range I can then use in calculations to reduce my uncertainty. Now maybe in Excel is not very well built to do calculations with ranges, but there are add-ons you can get, and they're free, that allow you to do calculations using a range instead of an exact number. And that gives you then also the result in a range. So anything that matters can be measured. Check out the work of Douglas Hubbard. I think you will find it interesting. And he has two books, one about business and one about cybersecurity. Douglas Hubbard also makes these, or encourages people to make these assumptions. Our problem is not as unique as we think. Others might have that same problem. We might have more data than we think we do. We usually need actually less data than we think we need, because that's one argument you always hear in cyber is quantification. It cannot be done because we need so much data to get this done. And the whole idea of analyzing something with statistics is to make a decision with the little data you have. If you have all the data you need, I don't need to do statistics, I can just look at it and make a decision. So actually we need less data than we actually think we need. There's a useful measurement that is much simpler than the measurement we're thinking of, and probably we need completely different data than we originally thought of. So these are good assumptions to make when you have a measurement problem. Modeling. We already talked a lot about modeling, and I really don't have too much to say about it. But modeling in the sense of making forecasts and estimates. A very good book is from Professor Philip Tetlock, and in all his research, he came out with the conclusion it is impossible to find any domain in which humans clearly outperformed crude extrapolation algorithms, less still sophisticated statistical ones. So with the smallest formula that can have only one variable or two, you can make better estimates than depending on your gut feeling. Like Jack already said, we always use models. This is just we use the mental model, when we should be actually using a formal model. Whatever decision you make, if you're not doing it through a calculation, you have used the model. And then the question becomes, is that model really better than a formal model? Which model is better suited for the decision I have to make? And of course, not every decision requires a formal model, but in many situations, in our problem space at least, a formal model will be much more useful than depending on the mental model. There are lots of models available, but most of the models we have in IT or in cybersecurity, they may be called, I don't know, conceptual models. So you could say the cyber kill chain or NIST or ISO are maybe conceptual models. And most of these models are trying to sell you on a future that you should reach, how to make changes and reach a particular target future, but they don't help you to make sense out of the problem you actually have. They make you a promise, change this, and then you will get this. And that's where FAIR is probably unique. First of all, it's the only mathematical statistical model that I know in IT or cybersecurity. And maybe we need to add to the list also now the FAIR CAM model. That's probably the second one. And FAIR really tries to help you to make sense of the problem space, to give you the tools to make a decision. That's totally different from what all these other models are trying to do. A few words on human biases. Now, we talked at the beginning and we said an organization, for example, is a complex adaptive system. And it's complex because there are so many different agents in it. But probably the most complicated one or complex one are the humans. Once you have humans in any system, things don't become as predictable as we thought it would be. So we might be thinking about, for example, motivations and incentives, and we think if you give people more money, they will be happy. And then suddenly you discover after you did this, no, another group is not happy anymore because they got less money, or they're actually not incentivized by money. They wanted a promotion. So many things that where we think casually, like do this, you get this. With people, it's much more complex. And I wasn't really aware too much about human biases when doing qualitative risk management. No one really brings it up. Everyone says, do qualitative risk management and make the decision and everything is perfect. And no one brings it up that we as human beings, we do weird things. But when I got involved in FAIR measurement, I started reading about human biases. And the good thing is that the quantitative risk management community acknowledges this bias. And they're actually offering tools to deal with it. So some biases, overconfidence, for example. We have the tendency to be overconfident in decision making. Anyone who has managed a project, they ask you when will it be done, you tell them 3 months, it ends up taking a year. And you have done 5 projects and all of them are late. But every time you're being asked, you tell them it's going to take 6 months and it ends up to be twice as much because of overconfidence. And FAIR or cyber risk quantification deals with it by using data, use ranges, and calibration training. I don't have a slide on calibration training, but that's you can read more about it on the website from Douglas Hubbard. That's specific training you can take to make you better at making estimates. And it has nothing to do with which domain you work or what kind of problem you have. I went through that training. Actually, all the questions you're going to be asked and trained on have nothing to do with cybersecurity or technical or whatever. It's mostly trivia questions. But when you go through that training, you become better at making estimates. And Douglas Hubbard shows that in his book. He has done this, I think, on 20,000 people, or I don't know how many people he has trained. And he shows you statistics how people before and after training become better at making estimates, even about trivia questions. Another human bias, anchoring effect. That basically happens when before a decision you bring up a number. The number has absolutely nothing to do with the decision. When you're talking about a big number, then whatever decision you might be making later on will be impacted by that number and will become bigger than you would originally have done it. And again, use data. That's what cyber risk quantification does. It does not depend on making subjective estimates, but using actual data. Availability heuristics, another bias. We tend to remember the things that just happened recently. So if you remember, you read an article about ransomware and how bad it is, and you're doing a ransomware